welcome to our final end-of-semester presentation on MCE5 machine reliability going into the 12-step MNET process. I would like to introduce my team.
Can everyone hear me if you talk to this volume? Everyone in the back?
Yep.
Alright, my name is James Heisinger. My personal safety commitment is to always wear safety glasses when necessary. My sponsoring company is Hudson Technologies.
Does everyone in the back hear me now loud and clear? My name is Brian Mateo. My personal safety commitment is to always maintain a clean workplace. And my sponsoring company is B. Braun.
Can everybody hear me okay?
Yep.
Good morning, my name is Tanner Thacker, and my personal safety commitment is to always wear the proper PPE in the required areas, and my sponsoring company is Rent Free.
We applied the 12-step process to our Visiwash machine and a manufacturing simulator that the college had.
The first step in the machine reliability process is to audit the machine. First, we need to audit your machine so you understand what the machine is doing and the current state of it. When we audited our Visiwash, we just got a score of 47 out of 100, which shows where our weaknesses are and where we can improve.
Now, improving machine backup. So this helps reduce machine's downtime and in some cases completely eradicates it. Now, as a result, costs reduced. Alongside that, efficiency increases. Now, in terms of the Visiwash, the backup we established was a separate eyeglass washing station, which is it wasn't ideal to our standards, but due to the time and resources we had at that moment, it was the best that we could do.
So the next step is to complete all open work orders. Before you start working on something, you want to make sure that any parts or processes that need to be done are completed. You don't want to start working on a machine and then have parts sitting around wasting space when they could have otherwise been put through the process beforehand. In the case of the Visiwash, it's a machine that we're creating from scratch, so there's no need for us to have any work orders at this point in time. And with the amateur trainer, it's from a discontinued class, so same case, no open work orders.
The next step is to divide the machine functionality, where you divide your machine into subgroups to make it easier to maintain and troubleshoot. In the case of our Visiwash machine, we separated it into 3 groups, being electrical, which was all of our electronic equipment, mechanical, which was all our moving parts, and fluid, which was all of our pumps and everything that dealt with the fluid.
The next step in the process is to clean the machine and list your parts. You always want to start with a clean machine whenever you're doing something like this. And we're going to use the list and verify those parts. We're going to use that list later on in the process.
Now, evaluating PLC inputs and improving HMIs. PLC stands for Programmable Logic Controllers, and that essentially is the brain of the equipment. Now, understanding the PLC gives you a better understanding on how to use the equipment and how it runs, including the PLC itself, which makes troubleshooting and finding the root causes of problems a lot less difficult. Now, for the Visiwash, we didn't use a PLC, but instead we used a microprocessing unit, a Arduino Uno. Oh, my bad. And for the HMI, we had push buttons, which initiated the wash sequence, and we had a flip switch, which armed and disarmed the device.
So with that, you should have a pretty good understanding of the machine that you're working on, and you now want to clarify a normal condition. It's important to have a normal condition because this is what you're going to see the machine working at when it is working properly. When it is not working properly, you should be able to identify it and stop it from running in case it causes bad parts or damage to the machine. The Visiwash, we have a certain standard that we strive for with how it runs, and whenever it deviates from that, we are able to immediately stop running it and troubleshoot it to ensure that it gets back to normal state.
The next step is to evaluate spare parts. This is where you find all the parts in your machine that may need to be replaced in the future and make sure you have backups for them and that they're all tested and working. In the case of our Visiwash, we could only find that the motors may need to be replaced in the future, and we went through and tested most of them, but we were not able to get through and test them all.
The next step in the process is to Kaizen A-ring parts. So with that list that we made previously, we identify the A-ring parts which are detrimental or imperative to your process. Then you want to Kaizen them, which means continuously improve them. So you're going to continuously improve the parts that are detrimental to your process. The way we did with the Visiwash is in the previous generation, we had a stepper motor which had a rigid range of motion and caused a lot of vibration. Now we upgraded to a smoother motor which is center mounted and helps with the structural integrity of the machine.
So now we're going to try and reduce the MTTR. MTTR stands for mean time to repair. What you're doing in this step is essentially minimizing the amount of downtime the machine experiences. In the case of the Visiwash, we did this by making an access panel at the top of the machine and putting all the electronics on a solderable PCB board. This way there's not loose wires hanging around that you have to reach through to try and troubleshoot things.
Now, FMEA. FMEA stands for Failure Mode Effect Analysis. And this helps improve the machine reliability and the overall safety of it. FMEA is also used to determine the likelihood of parts failing and the consequences of said parts failing. Now for the Visiwash, we use the FMEA analysis to determine what parts and what would be the most likely cause of failure within the Visiwash, and we were able to determine that water damage would be the primary cause.
The final step is to update your manuals and work instructions to reflect all the things you found in the previous steps. In our case, we don't have a manual or work instructions yet, so we just implemented routine checks to make sure the machine is running correctly. As many of you know, the last 3 semesters we've been working on our Visiwash project. This semester we decided to completely redesign it in the hopes of getting it to work.
So the first thing that we addressed was the size of the machine. The thing was way too bulky, the aluminum was not very uniform, a bunch of different dimensions, pretty unnecessary. Because of that, we went in and we changed the dimensions and made the machine much smaller. This way the form factor is easier to fit in different places, and it just makes more sense. We did this by taking the aluminum to the machine shop and machining it down 2 cents.
Additionally, with the previous design, we had rough edges on our acrylic panels due to unfortunate situations with the cutting. This semester, we were able to use a laser cutter. This laser cutter also introduced new obstacles with the size of the panels that we could cut, but they gave us uniform cuts. To beat that obstacle, we used a thinner, easier to cut, but also bendable and malleable material. This resulted in bending when we went to apply, so we tried to anneal it, we tried to do a lot of things, it didn't work. So we ended up using silicone and hot glue to seal the edges and remain waterproof.
Now for electronics, first we used a breadboard using jumper wires. That wasn't very neat, and it was difficult to troubleshoot at times. So we decided to improve on this and use a solderable PCB board. This made things a lot neater, a lot more easier to troubleshoot. Using that circuit diagram in the previous slide, the same listed components. Here to the left, you can see what we used before, the breadboard. You can see it's a mess. And to the right is the new and improved PCB board. Everything soldered on, a lot more compact and a lot more neat.
The next thing is our Arduino code. In the previous semesters, we were able to get our machine to work and run correctly, but we could not get it to stop. So we decided to go back and rework the code and make it simpler, and that actually worked, and we were able to get it to stop this semester. That's it for now. If there are any questions, you'd like to answer some?